Okay. Hello students. Once again, you're welcome to Waidsum University, and today we're still on this chapter 5, part 4. This is the router. Okay, this is called the router, the network router. Now, without much ado, let's begin. Now, first and foremost, you know, a router is okay. Let's take our highlighter. First and foremost, remember, a router is a layer 3 device. A router is what? A layer 3 device. Remember, the switch was a layer 2 device, although we have layer 3 switches, layer 4 switches, but a router is a layer 3 device, which means it uses the network addresses, right? So all layer 3 devices of the OSM model uses what we call the network address, right? So a router is a layer 3 device and it uses the network address, right? And what does it use this network address to do? It uses this network address to make the routing decision whenever it's forwarding data packets from one host to another on a network. So whenever it's forwarding a packet, a data packet frame from one host to another on the network, so it uses what we call the network address system to decide, to make decision where to send the data, where the data packet is coming from, and where this data packet, logical decision, and where this data packet is going to. So the destination and the source of the data packet and the destination of the data packet are established using the network address. All layer 3 devices uses the network address in making this decision. Now, the OSM model, as you know, it separates the network address responsibility to different layers. In the OSM model that we have studied before in chapter 1, you recall that the layer 3, or what we call the network layer, is one of the responsibilities. It includes handling the network addresses. That's one of the big job. The big job of the layer 3 is to handle the network addresses of the system or of the local area network, right? Now, the network address is also called what we call the logical address. The network address, we also call it the logical address. So this is quite different from the physical address. The physical address in layer 2. Remember, the physical address, a good example of the physical address is the MAC address. We've talked about this in layer 2 when we are doing the previous section, right? Using like the bridge and the switches, using the MAC addresses to learn about the direction where the data packet will be forwarded to make the decision on where to forward the data packets to, right? We've done that. So but we say the network in the network address or the router belongs to the layer 3, and layer 3s are called the network address. And we also said the network address are also called the logical address, right? Now, logical addresses, they actually describe what we call the IP address. IP address means Ethernet protocol address, right? The logical address, they actually define or describe or explain what the IP addresses are and the location in the network and their corresponding location in the network. So a logical address, or what you call a network address, actually describe what an IP address is and the location where they be found on the network. That's what this network address is. And also address the location of the host in the network. They locate the location of the IP address and also the location of the host on the network. Is that okay? Now let's move forward. Now, still on the router is configured to know how to route data packet that are entering any local area network and data packets that are exiting any local area network. This is by configuration, by design. Routers are configured to act like this. They already know and they are aware of where to send data packets to. They are configured to determine the route of data packet frames, where they're coming from, where they're going, where they're supposed to go by default. So this is how routers are being configured, okay, in a local area network. Now, this is quite different from the bridge that we've studied earlier on. They're different from the bridge that we studied earlier on. And we said the bridge or the switch or the hub, they are all layer 2 devices. And all layer 2 they use what we call the MAC address, or the Ethernet address. You can also call the MAC address the Ethernet address, which they use in making decision on where to send the data packets to the destination where they will forward the data packets to, for layer 2 devices, which are the bridge, the hub, the switch, which we did in earlier section. However, for router no. Routers are configured naturally to route data packets and establish where they're going when they are entering or exiting the local area network. And we said that routers are completely different from the switch and the hubs and the bridge. They're completely different from these three networking devices that we've mentioned in the previous section, right? Okay, now we say, unlike those one, the router uses the network address. We've established that fact. But those previous one we say they use the MAC address in deciding where to forward the data packets to, and how to forward the data to the host. Okay, so those other ones, the other first three we've studied in section 5.3, like the layer 2 devices, network devices, they use the MAC address. But router, they don't. They use what we call the logical address, or what we call the network address, which actually locates the IP address in the system. Is that okay? Now let's move on quickly. Now again, the routers are used to interconnect LANs in your campus network, right? They are used to interconnect the various local area network in the campus networks. Now the networks can be same protocol. Okay, you can have your network connected in a campus using the same protocol throughout, like the Ethernet. The Ethernet is a protocol, and also a token ring is a protocol. So we can use the same protocol for our local area network in the entire campus. In the entire campus configuration, we can use the same protocol, right? However, it's also a router is also adapted to be suitable for protocols that are not same, different protocols. Okay, so we can have like two technologies be used simultaneously or concurrently in the campus. So we can have the Ethernet protocol be used as a technology, and we can also have what we call the token ring be used as a technology same time. So the point we make is that router is suitable for whatever technology. You can combine two or more technology in connecting our various local area networks in a campus. Remember, in a campus you have you have more than one local area network in a campus that will be interconnected together with the help of a router. That will be interconnected together with the help of a router. Now routers also make it very possible for us to connect our to LANs, local area networks, outside the campus. Okay, the router makes it possible for us to connect our local area network even outside the campus. Okay, the campus networks can be interconnected with all the networks. Okay, especially to the around the country. We can connect. The router enables various LAN, various local area network in the country to be interconnected together. That's the point we're making. That's the point. So we say the router makes it possible for the various local area networks in your country to be interconnected together. Not just your country. The router actually makes it possible for us to have what we call the wide area network. It makes it possible for us to interconnect networks around the world, the whole globe. The router enables us to connect networks across the whole planet, the whole globe. Is that okay? Okay, let's move on quickly. Now, still on router, the figure you see here is a diagrammatic representation of a router every time we draw it for illustration in the textbook or in the books. So you can see like about two arrows going inward, two arrows going outward. So that's what you see, like entry into a router, data packets entry into a router through the ports, and also exiting the router through another two ports. A router is made up of multi-ports. A router is usually made up of multiple ports, not just one port. Okay, a router doesn't have a port. In fact, the minimum ports a router can have is 3 ports. A router cannot have less than 3 ports. The minimum ports a router can have is what? 3. Cannot be less than 3. Okay, router, the minimum. So it's made up of multi-ports. It can be 6, it can be 4, it can be 6, it can be 8, it can be. So a router can have multi-ports. Is that okay? And what you see, what we illustrated, this diagram, this figure, this picture, which is obtained from Cisco, this picture, it's just the diagrammatic representation, or the symbol of a router whenever we're doing the electrical drawing or we're doing the networking, computer networking. This is the symbol of a router that we normally portray or use to signify a router. Is that okay? Now, still, let's move on quickly. Then we say the arrow pointing in and out indicates that the data enters or exits through this route, to enter the router through this multiports. So this arrow is showing that data entry a router. This one also shows data is entering a router. This one is showing that data is exiting a router. And this one is also showing data is exiting a router. The router ports, they are bidirectional. Each port is bidirectional. What it means when we say bidirectional, router ports are bidirectional. What it means is that data can enter and exit the same router port. Data can enter here and also exit from here. They are bidirectional both ways. It has this functionality. So the data can exit through the into the router through this port, and can also exit out through this port. Same, all these four has that characteristics. They all have the same characteristics. So they are bidirectional. Every of the port data can enter and exit through that same port. Is that okay? Now, router ports are called the router interface. The ports are, we're going to show that in our next diagram. The router ports are called the router interfaces. Okay. Now the physical connections where the router connects to the network is called the interface. The interface is the physical connection where the router connects to the network. Okay. Now let's move on to the next one. Here is a router. Here is a picture of a router. This is Cisco 2800 series router interface. So this is a router. It looks like a DVD also, whatever you want to classify it as, or look. So this is a router. Now let's begin to look at. This is called the router interface. Each of these port is called the interface. Okay, where you plug out your RJ45 or whatever cables that you insert into the router. Okay, so these are called the interfaces. Now let's describe the interface one after the other. The first one is called the cursor, and it comprises the USB. You can see here, this router we can use with USB. You can use with USB. Okay, so a USB is an interface, meaning you can connect your laptop to a router directly, to maybe either to troubleshoot or to see something. You can use, because it has a USB port. You can even connect with a TV, with whatever it is. Now today's router, we even have what we call the HDMI, which enable other networking device connectivity with the router. So it has a HDMI, or most of these things, so that you can connect even your TV straight to it, and so many things that can be connected to it. But however, let's take a look at what we have here. So we say this is the cursor. This cursor, what is it used for? This called the cursor input. This where you input some what we call the ROC232 serial communication links is established through here. So this input provides the ROS232 serial communication link into the router. Okay, for the initial router configuration. So when we are doing initial router configuration, so this is where we input this serial cable. This is a kind of a cable. ROS232 serial communication link is put here to establish, to test run whether the router configuration is the programmable logic or controls in the router is now working. So this is where we use to initiate the initial communication link, and to test for the router and see if the router is working based on the configuration that it comes with. Okay, so the router is also showing the USB input port, which means you can connect other things. You can have your music, your whatever, and whatever it is, you can insert anything through a USB port into this router. Is that okay? So let's take a look at the next one. The next one is the auxiliary. Now the auxiliary, it's look at this one. This one is the one we call the auxiliary. The cursor is this one. Remember, let's go back to. So this is the cursor input. This first one. This one. If you want me to draw it, we can draw it. You can draw it. This is the console input. Is that okay? Now that's the first one. Now the second one is the auxiliary. This one, the one below it, directly below it. This one that is directly below it is the console input. It is the auxiliary. Now, what is the auxiliary input used for as an interface in a router? The auxiliary helps to input, or is used to connect a dial-in model into the router. Now, what is a dial-in model into a router? An auxiliary port provides the alternative way to routely log into the router whenever the network is down. So if the network is down, you use this auxiliary input to have provide an alternative way to log it to the router, anytime the network is down. Okay, so this auxiliary input uses what we call the RJ45 connection, or RJ45 jack, or RJ45 cable. Is that okay? So now let's move on to the next one. Then the next one you see here is called the serial input. There are two, this and this. The serial input. Now the serial input is a serial connection, and it has a built-in CSU/DSU. CSU, channel service unit, or data service unit. Channel service unit or data service unit. Okay. So what's the main function of this serial input? Now the interface is used to provide a tier 1 communication to the communication carrier. Okay, so what does that mean? This type of connection normally uses the RJ45, and the RJ45 cable has replaced the previous cable that we used to use for it, which is V35 cable. So RJ45 cable has replaced the old cable. So this is an inbuilt CSIU, or data service unit, and the interface is used to provide a tier 1 communication, a T1 connection to the communication carrier. That's what this is used for. Now let's take a look at the next one. The next one is this one. Okay, the next one is this one, which is the fast Ethernet. And the fast Ethernet is this. You can see these two yellowish one. They are called the fast Ethernet. The fast Ethernet input, these are the 100 megabit per second interfaces for router. The fast speed 100 megabits per second for input for the router is the fast Ethernet. Now let's go to the next one. The next one is this one. Take a look at this one, the voice interface card. This one, the voice interface, this one. And there are 4. This voice interface, there are 4. Okay, they have 4 input or 4 interfaces. So these ones are used for 4-line connections. From the name voice, from the name voice interface, you already know these are used for telephone lines. Okay, so with the router you can connect to the telephone line, like the one we have in office or even in our homes. So you have a telephone line connected to the router, so you can call out and receive a call. Not the mobile. I'm not talking about a mobile phone. I'm talking about the network phone. Okay, so you can call and you can receive call and so on and so forth. So it has 4 input for voice, for telephone to be connected. Is that okay? Now this router can be programmed as a small PBX. PBX means the private branch exchange. PBX is used for telephone communication. It's used for telephone communication. So these 4 input, which is called the voice interface, they are used for as PBS. Okay, they are used as PBS for use in a small office. So this type of router, you can use it for a small office so that the office can have its own telephone line, what we call the LAD line. You know, in Africa we normally call this the LAD line. Okay, so these ones are for such communication. Okay, with a router you can have your phone connected, interconnected to it, and these are supposed to be provided by telecom service providers. Like in Malaysia is Telecom Malaysia, which is TM. Okay, which is TM. TM provides these devices, this equipment, and these equipment are usually manufactured by Cisco, by Huawei, and so many other hardware manufacturers, network hardware manufacturers. Is that okay? So that's it. That's what it is. Let's move on to the next one. The next one is the modem. The modem. This one, these 2 ports, or these 2 interfaces, they are called the modem. Now what are the modem used for? This is the interface with the RJ11. It uses what we call the RJ11 jacks, and has 2 V90 analog Ethernet modem. Okay, so 2 V90 analog Ethernet modem. These modems can be used to handle both the incoming and outgoing modem calls. So it's to handle the incoming and outgoing modem calls coming to the router. Is that okay? That's what it's used for. Now let's go to the last, but not the least. Here we talk about the FXS and DID. Now this is an interface with 4 pin or 4 entries, right? it has 4 ports. Okay, now we have what we call the FX and DID, voice and fax. Okay, these ones are for voice and for fax interface card. Now the FXS is a foreign exchange interface that interconnect directly to a standard telephone. Okay, the FXS is a foreign exchange interface that connect directly to a standard telephone. That's what this foreign exchange interface, FXS, what it represents, or what it stands for, what it's used for. Then we say the DID is direct inward dialing, and it's a fixtures that enable the caller to directly call an extension on a PMV4. So let's say the whole essence of this DID is that, you know, when you have a router, when you have an office space, okay, the call comes into one through the router and then can be forwarded. You can have an extension. Maybe the boss office can have an extension, the manager's office you have an extension. So the job of the DID is to help to extend and forward the call to the office upon which is designated to. Is that okay? Now let's move on. Now here is what we call the AUI ports. Now the AUI port, first of all, is a 10 megabit per second internet speed. Okay, and it's the meaning of AUI is what we call the attachment unit interface. The AUI means attachment unit interface in network. Okay, this device is a converter. This device is a converter. It can convert the 50 pin from the AUI into 8P RJ45 8 pin. So one of the job it does, this equipment AUI, is that it can convert the 50 pins from AUI ports into 8 pins of the RJ45 connector. Okay, that's what it does. So it's like a converter converting from one interface or understanding or language to another interface. Okay, so we say it converts 50 pins of the AUI into RJ48 pin of RJ45. So this is a good example that we've shown, and you can see physically how it looks. Okay, how it looks physically. Then we also say that this is a media converter. So it's a media converter, and commonly they use with computer networks in layer 1. Okay, they are using layer 1 to adapt the layer 1 or the physical layer technology from one technology to another. So because the technologies that are used by these interfaces are different, so the AUI is to actually enable the conversion from one technology to another, and they're usually using layer 1. Is that okay? Now let's move on quickly. Now this is an example. What you see here is a good example of a Cisco router. This is a Cisco 7200 series router. Okay, so this was taken from Cisco's archive, okay, as illustration for this course, as illustration for the students doing networking, computer networking. Okay, now let's move on quickly. Here is an example also from Cisco. Here is an example of a Cisco V35 DTE cable. This is a DTE cable. Okay, so when you get to field as an engineer or as an administrator, as a network engineer, so you should know all these things because you've studied them already. You see them in the classrooms, so you should know them. This is what we call the Cisco V35 DTE cable. Okay, so let's move on quickly. Now, after this, with the light of this, we hope we've showed you what a router is, and how it looks physically, diagrammatically, and the conversions and the interfaces that are used with routers, and the functionality of each of the interface, and every other thing that goes with router. So we hope you get the scope of this subject matter. So at the end of the day, summarily, what we have looked at is the network address. We say a router is a layer 3 network address protocol, right? And then we say it's also called a logical address, which helps us to locate the IP addresses in the system, in the network. So we say we describe the router interfaces and their functionality. We talked about the the attachment unit interface, the AUI ports, and then we talked about the media converter, that the AUI port is a media converter. It converts the AUI 50 pins into 8 pins of the RJ45 connector. So with this, we come to the end of this section. Thank you very much for your attendance. We see you in we hope to see you in chapter part 5 of this course. Thank you.